welcome back to QBT. So in our last video we talked about the pressure that's exerted by a fluid and we talked about its equation, but in this video we're going to talk about how we actually get that equation. We're going to talk about its derivation, and this is a really elegant derivation, okay? And if you check out this tutorial video, it's going to explain it to you step by step, okay? And it's going to be really helpful, particularly for those of you that are doing your A-levels, okay? You might be asked to derive this equation, so pay close attention to this tutorial video.
Okay, so how are we going to approach this question? The question asks us to derive the equation for the pressure exerted by a vertical column of fluid, okay? And we know that this equation is pressure is equal to height times density times gravity, okay? So that's our equation that we use. But obviously we need to learn how to derive this equation, okay? And the question is, how do we do that? Well, we take it one step at a time, as we do with everything in physics, okay? Now, let's consider our vertical column. Okay, here we have our vertical column and it's got fluid in it. Now, we can say that at the base, okay, at the very bottom, right, where all that pressure is being exerted, we can say that the pressure at the base is going to be equal to the weight of the column divided by its area, okay? So we're saying that at the base, the weight is equal to, the pressure is equal to the weight divided by area. And that's because pressure is equal to force divided by area. And because W is equal to mg and F is equal to ma, right? In this case, the acceleration is effectively due to gravity, right? So in this case, we say that the weight and the force are synonymous with one another, which is why we're able to say that the pressure is equal to the weight divided by the area, okay? Because the pressure that is exerted by this particular column of fluid is subject to the gravitational field strength, okay? So we can say that in this case, weight and force are synonymous with one another. So this allows us to construct the first part of our question, okay? Where we say, of our derivation rather, where we say that the weight is equal to the mass of the column multiplied by the gravitational field strength. Now, what do we do from here? Well, we say that the mass, because density is equal to mass divided by volume, if I rearrange that, I can say that mass is equal to rho v, okay? So weight is equal to rho v times g, okay? Weight is equal to density times volume times gravity. Great. Now what do? Well, I rearrange my volume a little bit, and I say that weight is equal to density times area times height times gravity, okay? If volume is in meters cubed and area is in meters squared, effectively what I'm saying is that the area multiplied by the height is going to provide me with a volumetric measure, okay? So I'm doing base times length times height, okay? And then what do? Well, then effectively what I'm doing at this stage, because we've assumed that weight and force are synonymous with one another, what we can do is equate our weight to force, okay? And if pressure is equal to force divided by area, we can divide our entire expression by area. So we can say that the pressure is equal to our force, which is here, okay? Because we said that F equals W, which equals our expression. So pressure is equal to density times A, H times G divided by A, our area, okay, from the here, yeah? We divide through by area, and we see that pressure is equal to rho times H times G, okay? And that's how we derive our expression. Now, from this expression, we can conclude a few things. We can conclude that the pressure is proportionate to the height, okay? So as we increase height, as we increase depth, we increase the amount of pressure that's exerted by the fluid. We can assume that the more dense the fluid, the greater the pressure it exerts, okay? If my density goes up, then obviously my pressure has to increase. But we can also assume, right, from this part of our calculation, that the pressure does not depend on the cross-sectional area, okay, of the vertical column, okay? So those are some assumptions that we can make. So we say that pressure does not depend cross-sectional area. Okay, and that's how we derive our equation.
Okay, so I'm hoping that was helpful and you now have a more comprehensive understanding of how we derive the equation for the pressure that's exerted by a column of fluid. If you have any questions about it, then just leave them in the comments below. Please like and subscribe and share, because it really helps grow the channel and helps us in turn get more quantum content to you guys. But in the meantime, I'll see you next time at QBT. Bye.